Journey with us to the heart of our cosmic home, where a supermassive black hole rules over a realm of extreme physics and mysterious phenomena. From ancient star clusters to enigmatic radio signals, we're exploring the Milky Way's most fascinating region. Let's talk about Sagittarius A, the colossal black hole at the center of our galaxy. Picture something 4 million times heavier than our Sun, packed into a space smaller than our solar system. This cosmic giant sits about 26,000 light-years from Earth, quietly influencing everything around it with its incredible gravitational pull. Scientists first noticed something strange in this region back in the 1930s, when they picked up unusual radio signals, but it wasn't until the 1970s that we started to realize what we were dealing with. Think of Sagittarius A as the Milky Way's anchor point, a cosmic heavyweight champion that keeps billions of stars, including our Sun, in their cosmic dance around the galactic center. The way it bends space and time around it is so extreme that even light can't escape once it passes the point of no return, called the event horizon. Let's zoom in on one of the most crowded neighborhoods in our galaxy, the nuclear star cluster. Imagine cramming several million stars into a space just 30 light-years across. That's like trying to fit all of Los Angeles into a coffee cup. These stars aren't just any ordinary bunch. They're some of the oldest in our galaxy, with many being over 10 billion years old. What makes this cluster truly special is its location right next to Sagittarius A. These stars are literally living on the edge, orbiting dangerously close to our galaxy's central black hole. The gravitational forces here are so intense that these stars move at incredible speeds, some zipping around at millions of miles per hour. It's like watching a cosmic version of rush hour traffic, but instead of cars, you've got ancient suns playing a high-stakes game of cosmic tag. Now let's explore one of the most puzzling features of our galactic center, the mysterious radio filaments. These strange structures look like giant cosmic threads, stretching up to 150 light-years long, but only a few light-years wide. First discovered in the 1980s, they're like nothing we've seen anywhere else in the universe. Imagine giant glowing strings floating in space, perfectly straight and organized, emitting strong radio waves. Scientists have spotted hundreds of these filaments, all neatly arranged and pointing perpendicular to the galactic plane. What's even more fascinating is that they appear to be held in place by powerful magnetic fields, acting like cosmic energy highways. While we're still debating their exact origin, some think they might be the remnants of ancient magnetic events, or possibly the result of particles being ejected from Sagittarius A. Think of them as the galaxy's own version of the Northern Lights, but on a mind-bogglingly massive scale. Let's explore the central molecular zone, a massive cloud of gas and dust that's essentially our galaxy's most active star-making factory. This region spans roughly 1,000 light-years around Sagittarius A and contains enough material to make about 60 million suns. Here's where things get really interesting. The gas in this zone is incredibly hot, around 100 degrees Kelvin, while typical cosmic clouds are much colder at about 10 degrees Kelvin. It's like comparing a sauna to a freezer. The intense magnetic fields and turbulent forces from nearby stars create perfect conditions for stellar birth. Picture cosmic ingredients being tossed around in a giant space mixer, occasionally clumping together to form new stars. Despite having just 5% of our galaxy's gas, this region produces about 10% of all new stars in the Milky Way. Let's dive into the wild world of physics near our galactic center, where normal rules just don't apply. Close to Sagittarius A, space becomes like a cosmic funhouse mirror, where everything gets twisted and stretched. Gas clouds spiral inward at nearly half the speed of light, heating up to millions of degrees as they're pulled toward the black hole. This creates a brilliant light show that astronomers can actually observe. The gravitational forces are so strong here that time itself moves differently. What feels like an hour to a star near the black hole might be several hours to us on Earth. Think of it like a giant cosmic whirlpool, where everything gets stretched into long spaghetti-like strands as it approaches the center. Even light rays get bent into crazy paths, creating multiple images of stars behind the black hole. Let's explore one of the most spectacular features of our galaxy, the Fermi bubbles. These massive structures are like giant cosmic balloons extending above and below our galactic center, each one stretching an incredible 25,000 light-years. Discovered in 2010 by NASA's Fermi telescope, these bubbles are filled with superheated gas and high-energy particles, glowing with gamma rays. Think of them as ancient cosmic burps from our galaxy's black hole, created when Sagittarius A had a particularly big meal millions of years ago. The energy packed in these bubbles is mind-boggling, equivalent to about 100,000 supernova explosions. They're like giant cosmic fossils, telling us stories about times when our galaxy's center was much more active and energetic than it is today. Now, let's tackle one of the most mysterious players in our galactic center, dark matter. Think of it as an invisible cosmic scaffold that helps hold everything together. While we can't see it directly, we know it's there because stars near the galactic center move way faster than they should based on the visible matter alone. Scientists estimate that dark matter makes up about 85% of our galaxy's mass, forming a huge sphere or halo around the center. Near Sagittarius A, this invisible matter is packed incredibly densely, creating a sort of dark matter spike. It's like having an invisible support system that works alongside the black hole's gravity to choreograph the complex dance of stars and gas in the galactic core. Let's explore one of the most mind-bending aspects of our galactic center, how time and gravity behave near Sagittarius A. Imagine you're watching a clock near the black hole. It would tick noticeably slower than one on Earth due to extreme gravitational forces. This isn't science fiction, it's Einstein's relativity in action. If an astronaut somehow survived a close approach to Sagittarius A, they might experience 1 hour, while we on Earth would see several hours pass. The gravity is so intense that it literally warps the fabric of space-time, creating what scientists call gravitational lensing. This means that light from stars behind the black hole gets bent around it, sometimes creating multiple images of the same star, like nature's own funhouse mirror. Pretty wild, right? Let's unpack how astronomers managed to study this bustling cosmic metropolis, located 26,000 light-years away. The journey of light from the galactic center to our telescopes is quite the adventure. When light leaves this region, it has to push through thick clouds of cosmic dust and gas. Imagine trying to see through a sandstorm that stretches across thousands of light-years. That's why we rely heavily on infrared and radio waves, which can penetrate this cosmic fog much better than visible light. The Very Large Telescope in Chile and the Keck Observatory in Hawaii use advanced adaptive optics. Think of it as cosmic glasses that correct for Earth's atmospheric blur. These tools let us track stars whizzing around Sagittarius A like cosmic race cars, giving us front-row seats to this incredible celestial show. Looking ahead, we're on the brink of some incredible discoveries about our galactic center. The next generation of telescopes, like the James Webb Space Telescope and the Event Horizon Telescope Array, are about to give us an unprecedented view of Sagittarius A. We're hoping to finally understand some major mysteries. Why is our central black hole surprisingly quiet compared to other galaxies? What's powering those bizarre radio filaments? And perhaps most intriguingly, could there be smaller black holes orbiting the big one, like cosmic satellites? Scientists are particularly excited about catching a possible star being torn apart by the black hole's gravity, a cosmic feast that would teach us volumes about extreme physics. The next decade promises to be a golden age for galactic center research. Thanks for joining us on this cosmic journey through our galaxy's mysterious heart. If you enjoyed unraveling these space secrets, don't forget to like, subscribe, and share this video. Stay curious, and we'll see you in our next astronomical adventure.